Hello, I'm Minxing from Professor Jesper Technical School. So today I will introduce one of our B324 course project, which is the AlphaFold2 reproduction and improvement. Yeah, so here is the overview of today's contents. It will include the motivation, the structure of AlphaFold2, the modified model, and experiment and the outlook. Okay, so here first is the motivation. So specifically, the predicting the protein structure from only the protein sequence is an open problem in the computational biology. And AlphaFold2, which is recently proposed by the DeepMind, is a revolutionary model, but it is not open source. So we try to tackle and reproduce this model and have and hope to have some improvement. Okay, so here is a very brief overview of the AlphaFold2 AlphaFold2 structure, which is shown on this is from the DeepMind website, but not very clear in the technical detail. Yeah, so we can see that their input is the sequence as I mentioned before, and then they query this sequence on the MSA dataset, which is a multi-sequencing alignment dataset, and they get some other sequence. Yeah, okay, and then they use a sequence dataset and multi-sequence alignment dataset to train on their deep learning models. Yeah, so that they can get representations and then give some types of outputs, including the pairwise distance, structure model, and also the confidence score for the prediction. Okay, and here is our idea and modified model. So here we have used a SD3 transformer model. Yeah, this is a new type of transformer model, which here have very good property on the preservation for the symmetric, for the symmetric property. Yeah, so first is we build a baseline model, which is just use the the mass language model training strategy in the natural language processing, which is just train using the sequence input and go through the SE3 transformer and finally give the content map prediction output, and we do this supervised learning. Yeah, so this is the baseline model, and secondly, we build a two-stage the pre-train and fine-tune model. So the input is multi-sequencing alignment. And then in the first stage, we do the mass language model pre-training, which tries to reconstruct the raw input from the noise input. Okay, and in the second stage, we fine-tune this model. Yeah, so as you can see, in the stage two, we first input as the MSA data, and we use a pre-trained model from the stage one to get the representation, and from the representation, we give it to the E09 model and finally output the 3D structure prediction. Okay, and we also do some experiment on the CSP 12 data set on our baseline model. Yeah, and I have also collected the MSA data set from the Harvard University's group. Yeah, and I have shared it on the iBest, which will be available for every users. Yeah, so if you are interested, you can access it on the iBest reference data set. And okay, and here is our baseline result, and this experiment is already trained on the sequence data as the baseline result. Yes, so we can see that the SC transformers performance is close to TR Rosetta. TR Rosetta is now the best model in the 3D protein structure prediction. Yes, so we can see that we also have space for improvement because this is not a fully trained model. And finally, I will give some outlook. So firstly, we will continue and fully train the model and see the performance on the available data set. Yeah, that is the 4 terabyte data set I have mentioned before. And second thing I want to say is that although it is only a course project, but I think the advanced methods we develop from this problem can be transferred to other domain of the computational biology, which is valuable. So finally, thank you for your listening.